Hello, welcome to the Control of Mobile Robots course, the hardware lectures. My name is Roland O'Flaherty, and I am a robotics PhD candidate here at Georgia Tech. Now, with Massly Online Open Courses, or MOOCs, what you're taking here, they're great because thousands of students all around the world can get access to high-quality lectures from top-notch professors at a reasonable cost. However, what is often missed in the MOOC experience is the ability for the students to get hands-on experience and take what they learn in the classroom and apply it to real-world applications. For example, here at Georgia Tech, the students who take the Control of Mobile Robots course get a lab section where they get to take the theory that they learned in the lectures and apply it to these robots here called the Caperas. But the problem with these robots is that they're very expensive, in the thousands of dollars. And there's no way students who are taking MOOCs can go out and buy one of these and take the theory that they learned in the lectures and apply it to this. So what we're hoping to do is give the students, give you guys, the know-how to build a robot that costs relatively a small amount of money, especially compared to the Capera, and you can buy all the parts online, build it at home, and then run the control algorithms that you learn in the lectures on this robot. So this is the robot that you'll be building in the course, and it's called the QuickBot. So over the next 7 weeks, I'll be taking you through the know-how on how to build the robot, run it, and then also, in the later portion of the course, I will be giving it an overview of physical computing so that you can actually take the microprocessor that's on the robot and use it for other projects and applications. So again, the first 4 weeks will be building, so buying, building, and running the QuickBot, and then the next 3 or so lectures will be going over physical computing. So the QuickBot is a relatively inexpensive differential drive robot, the same as Capera. That means it has 2 wheels and 2 motors, and it drives like a tank. It has a powerful microcomputer on it, and that's the BeagleBone Black. It has Wi-Fi to connect so you can run it wirelessly. It has wheel encoders so you know how far the wheels have gone. And it has IR distance sensors so you can measure distances pretty coarsely but use it to maybe avoid obstacles. What you're going to do is buy the individual parts online and build them at home. And then you're going to interface with the QuickBot using the MATLAB SimIM simulator. So, again, you get to apply the theory you learn in the lectures to a real robot, the QuickBot. So now what I want to do is go over the parts that you'll need in order to build the QuickBot. So the first set is the chassis. So the chassis is going to cost around $17.50. You're going to buy it from SparkFun. It's the Magician Bot. And the Magician Bot itself is $15, but you're also going to need an extra battery holder. Then there's the wheel encoder. So SparkFun is just coming out with this. And this is specifically designed for the Magician Bot. That's going to cost about $10. And that allows you to measure the distance that the wheel has turned. Next is the BeagleBone Black. So this is a large chunk of the price of the robot. It's going to cost about $63.50 for all the parts. The BeagleBone Black by itself is $45. But it's also recommended that you buy a power supply to run it so you don't have to run it off battery or the USB cable, an Ethernet cord, and an SD card in case you want to reflash or put a different operating system on the BeagleBone Black. Next is the Wi-Fi module. This is about $13. This allows you to connect it to your home network and drive around the QuickBot wirelessly. Then we have the power supply components. So the BeagleBone Black, or the QuickBot, is going to run off 8 AA batteries, and so those are hooked in series that give you around 12 volts. So this brings that voltage down to 5 volts, which is needed for the BeagleBone Black to run. And so here are the components for that. And what we're trying to do with this robot, the way I've designed it, is to make it as simple to build as possible. So I've really tried to limit the soldering that's necessary. There's only one component that needs soldering, and that's actually the encoder, the header pins on it, so just 6 little pins. The rest is all wired up via breadboard, so shown here. Shown here. So it makes it really simple to build. So let's move on. You'll spend about $9 on nuts and screws and about $14 on wires. These are both male-to-male jumper wires and female-to-male jumper wires. Spend about $4 on batteries. Miscellaneous solder and electrical tape will be about $5. Now, a big cost is the IR sensors. Unfortunately, each IR sensor with the wire costs about $16 or so, and there's 5 on this. Now, you can build the robot without the IR sensors and drive it around and just use the wheel encoders, but you won't be able to do the object avoidance, but you'll have a significant savings in the cost. So in total, the QuickBot without the IR sensors is going to be around $150, and the QuickBot with IR sensors is about $235. This is a significant cost savings versus, say, the Capera robot, which costs thousands of dollars. So we tried to make the QuickBot in the range of about a high-quality textbook. So the tools that you'll need to build the QuickBot are a screwdriver. This screwdriver actually comes with the kit, the Magician Bot kit, so you don't have to go out and buy a screwdriver if you don't have one. You will need wire cutters, needle nose pliers, and a soldering iron for soldering the header pins on that encoder board. If you don't have a soldering iron, they cost about $10. You can get one at your local Radio Shack or order one off Amazon. So the vendors that you'll be getting all your parts for online, what I tried to do in designing the QuickBot is both limit the cost and limit the number of vendors that you have to go to buy all the parts. So we have ADA Fruit. They're an awesome online vendor. They have great tutorials. They actually have great tutorials for the BeagleBone Black. We have Amazon. Everyone knows Amazon. Logic Supply is where you'll buy the Wi-Fi module. I found that the Wi-Fi module from other vendors, such as the little one from ADA Fruit, does not work very well. You need one with a large antenna. So the one from Logic Supply works excellent. Muser Electronics is where you'll get the pieces for the power supply. That's like your resistors, your voltage regulator, your capacitor. And SparFun, a large number of the components come from there. That's where you get the chassis, the encoder, and many of the other components for the QuickBot. The complete list of all the parts, links to where to buy them, is online. So go to the resource section of the course and you can find the list there. And now what I would like to do is give you a quick demo of the QuickBot driving around so you can see it drive around. And this is me driving around just on what we call teleoperation, just via remote control. Now this is different from a remote control car because it's actually processing commands. I'm sending it via my computer to tell it what to do. And those commands could also be coming from MATLAB, which you'll do later in the course, to have it avoid obstacles or do whatever you want. It's a robot. So let me show you the QuickBot driving around. All right, so here I have the QuickBot, and I've connected to it via Wi-Fi from my computer. I just want to quickly show you the parts on the QuickBot. Here we have the batteries. Here we have the BeagleBone Black and the Wi-Fi antenna. And we have our 2 motors and our wheel encoder disc. Our wheel encoder is actually in here. And then we have our 5 IR sensors around the outsides of the QuickBot. All the wiring and the power supply is tucked inside here. So what I'm going to show you here is teleoperation, like I said. I'm going to be driving it around via a joystick that's connected, or a gamepad that's connected to my computer. All right, so let's drive it around. So it drives like a tank does. I can control each wheel individually. Here's the right one going forward and backwards, the left one going forward and backwards. And I can drive it straight. So right now I'm not using any of the sensors. I'm not using the encoders. I'm not using the IR sensors. It's just driving via teleoperation, just so you can get an idea of how quickly it will move and how mobile it will be. Okay, so that was the demonstration of the QuickBot. Now, before I sign off for this week, I just want to emphasize that building the QuickBot is completely optional for the course. It has no effect on whether you're going to get your certificate. I do think it would be a good idea for you to build it because then you get hands-on training or hands-on applied of the theory that you learn from the lectures to an actual robot. And one thing before I go, I want to say that it's probably a good idea to use rechargeable batteries because the batteries do go quickly with the Wi-Fi and the BeagleBone Black on. So rechargeable AA batteries will be the best thing to use. And lastly, before I leave, I want to state why it's called the QuickBot. And so this isn't because it drives around particularly fast, but more it's easy to build, and you should be able to build it in a half hour or so. And so next week, I'm actually going to go through building of the QuickBot, and I'll see you then. Thanks.